So remember, a series is just a sequence with plus signs. So 3 plus 9 plus 15 plus 21. And it is arithmetic if there's a common difference between the terms. So in this case, D is the common difference, plus 6. And of course, the whole point of having a bunch of plus signs is to add those up and find a value for that sum. So luckily, when we're talking about arithmetic series, we have two really great formulas to work with. You can find the sum of the first n terms by using the formula n over 2 times the first term plus the last term. And the other formula to find the sum of the first n terms, n over 2 times 2 times the first term plus n minus 1 times d. And you'll recognize this as looking quite a lot like finding the nth term of a sequence. All right, so a couple of examples to illustrate the point. We want to find the indicated sum of the series -3 plus 2 plus 7 plus 12 plus all the way to 157. So I sort of want to use the first formula because I have a first term and I have a last term. Problem is I don't really know what n is. I don't know which term 157 is. I know the value, but I don't know which one it is. So I'm going to revive a formula from a previous lesson, and that's the explicit formula for the nth term. So to find the nth term, I want the first term, I have one, plus n minus 1 times d. Well, d is pretty easy to find. -3 to 2 means I had to add 5, and then just double checking that it holds across everything I have so far, and 7 plus 5 is 12. So that's true. I have I have plus 5 for d. I'm solving for n. I have an nth term and I have a first term. Good. So I think I'll go ahead and plug everything in to begin with now. I usually like to solve the literal equation, but I think this time I won't. Now my distributions. Lost my notation for a minute there. And now I can solve for n. (157) plus 8 is 165. Divided by 5 is, so let's see, 100 divided by 5 is 20, 60 divided by 5 is 12, and 5 divided by 5 is 1. So 20, 32, 33. So I know that n is 33, so I know that this is the S 33rd term. Oh, excuse me, the A 33rd term. Now I can use my formula. I have Sn, the sum of the first n terms, equals n over 2 times the first term plus the last term. And from here on out, the whole thing is pluggy-chuggy. The sum of the first 33 terms is 33 divided by 2 times the first term, -3, plus the last term, 157. And then working across, let's say 33 halves times 154. We can divide this to make things simpler. 33 times 154 is 50, plus 25 is 75, plus 2 is 77. And I don't think there's an easy trick for this, so I'll just use column multiplication. 7 times 3 is 21. 3 times 7, 21, plus 2 is 23. The same thing's going to happen again. 1, 4, 7, 2,741. That's not right. Poor handwriting. This is a 3, so this is a 5. 2,541, and I know that's the correct answer. So next we want to find the 17th partial sum. So we're looking for S sub 17 of the arithmetic sequence, or excuse me, series 53 plus 31 plus 9 plus, and we don't know the last term because that's what we're looking for. So in this case, I want to use the second formula because this is what I'm looking for, Sn. I know what n is. I know what the first term is. I will be able to figure out the common difference, and n minus 1 is something I know. So I'm going to use the second form. So S sub 17 equals, I'll go ahead and start plugging in. Well, first let me find the common difference. So 53 to 31 means I had to subtract 22. So let's double check. If I subtract 22 from 31, 22 plus 9 is 31. So I know that that's my D. So now put it into the formula. I'm looking for the sum of the first 17 terms, and that's n divided by 2 times 2 times my first term plus 17 minus 1 is 16 times D. Now just pluggy chuggy. 17 halves times 106 minus 22 times 16, 12, 13, 22, 2, 5, 3. 352 minus 106 would be a 6, so that's a 4. Take away 0 is a 4. 3 take away 1, 2, 46. 17 times 246 divided by 2 is 17 times 123. I am not going to do that with column multiplication. 17 times 123. 2,091. And of course that's a negative because I didn't put a negative right there. So that equals negative 2,091. Easy peasy. All right, last example before we do a real world scenario is we want to find, well, let's write it out first. If we have the sum of n starts at 10 and ends with 32, n plus 6, then we want to find, obviously, what would seem to be the 32nd term, but because we're starting in at 10, then we'll have to make an adjustment for which term we're talking about. And this can be a little bit tricky. I'm going to show you how to think about it. If 10 is the first term, and if it went 10 to 11, then the second term would be 11, which means from 10 to 11 is actually 2 terms because you have to include 10 and then each additional 1. If 32 were a 12 instead, I would start with 10, the term that was created by substituting 10, and then the term that was created by substituting 11, and then the term that was created by substituting 12. And so there would be 3 terms, not 2. So in this case, I'm looking at 32, take away 10 is 22, but then I have to add back in the first term 10. That makes sense? I'm hoping. So that we're looking actually for the 23rd term of this series. Okay, so I think I want to use, I know n, I'm looking for the 23rd term, I know n, and I have a way to get the first term, but I don't have an explicit formula to get me to the last term, the 23rd term. So I think I'm going to have to use the second formula. And let's see what I have so far. So the sum of the first n terms is n over 2, well I know there are 23 terms, times 2 times the first term, so I'm going to need to know what the first term is, plus, well n minus 1 is 22, times the common difference. So I'm going to need to know what the common difference is. So the two things I'm going to have to figure out using my formula are the first term and the common difference. So that just means I'm going to need 2 or 3 terms. So let's go ahead and find a sub 1, which is n plus 6 or 10 plus 6 equals 16. So I can put 16 here, and now I need to just get a couple more terms so I can figure out the common difference. So the second term would be 11 plus 6 equals 17. The third term would be 12 plus 6 equals 18. So the common difference is plus 1 and plus 1. So now I can put that in here. And then finishing up the arithmetic, I have 23 thirds times 2 times 16 is 32 plus 22. This is halves. 23 halves times 32 plus 22 is 54. 23 times 54 divided by 2 is 27. And again, I think I'm going to go ahead and use my calculator again. 23 times 27 is 46. Which is clearly not true, times 27 is 621. All right. Okay, so that's working with formulas to find the partial sums of arithmetic series. Now, let's do a word problem, because there's nothing as much fun as a word problem in maths. Okay. For a fundraiser, your class decides to sell spirit headbands for $2 each. The manufacturer charges $100 for the first 100, and then $125 for the second 100, $150 for the third 100, etc. So you project sales of 500 headbands. How much do you expect to earn? Okay, well, let's put this together. So clearly we have iterations because the manufacturer is charging you one price for 100 and then incrementing up another price for the second 100 or for 200 and incrementing up another price for the third 100. So let's say I sub 1 is $100. A sub 2 then, the second iteration would be $125. A sub 3 is $150. And then the third one or the fourth one, you can imagine because it says etc., we can see pretty clearly here that we have a common difference of 25. All right, so we would imagine that the fourth 100 would cost you 175. So you're saving money with each additional 100, but you have to get through that previous 100 at a higher price. So 175. All right, so in order to figure out how much we expect to earn, it's easy to figure out how much we're going to make, right? If we think we're going to sell 500 headbands for $2, we're going to make, or we're going to sell, let's say that because it's not make yet, we're going to sell $1,000 worth of headbands. And then we want to subtract our cost, and that'll tell us how much we make. So our cost can be determined by figuring out how much it's going to cost us for 500 headbands, because that's all we want to buy is 500 headbands. Well, it's actually easy to see. We could do this without any kind of series. Our next iteration would be 200. If we just add these up, it'll tell us how much we're going to spend. But let's go ahead and use the formula that we have. And which one do we want to use? We have a sub 1 equals 100. And we actually have a sub 5, but let's pretend like we don't know because we're trying to learn a process here without using numbers so big that we get bogged down in them. So let's pretend that we don't know. A sub 1, we have our common difference is 25. So which formula do we want? We have a sub 1, we have a sub 5. Oh, and we know that n equals 5 because if 100 is n equals 1 is 100, n2 is 1 is the second 100 I sell, n3 is the third 100, n4 is the, so n equals 5. So let's look at the formula that we want to use for a, d, and n. Well, we don't know what a sub n is. We know what a sub 1 is. We know what n is. We're going to have to use this second formula. So the sum of the first 5 terms is equal to 5 over 2 times a sub 1 plus 5 minus 1 is 4 times the common difference, 25. Let's calculate this out. 5 halves times 200 plus 100. 5 halves plus 300. Cancel, 150. So 5 times 150 is 500 plus 250 is 750. So we are going to pay $750. 1,000 take away 750 is $250 earning. But let's go back and check this number against our logic. Now let's come back. We do know this value because we could have figured this out on our own. 5 plus 5 is 10. Carry the 1. 2, 3, 8, 15. Carry the 1. 2, 3, 4, 5, 6, 7. $750 is what we would have figured out had we just kept doing this logically. But what if we had decided to sell 5,000 headbands? Obviously, this is not a process you want to go through. The formula would take you there so much easier.